In this first lab, I will be discussing the constant velocity of a moving object, Newton's second law. When there is a constant velocity, there is no net force on the object. As you can see here, with Newton's second law, the net force is equal to 0. Therefore, in the equation, it goes from final velocity equals initial velocity plus the net force over mass times the change in time. But because the net force is 0 when an object has its constant velocity, it will just be equal to final velocity equal to initial velocity. For my experiment, I rolled an orange across a table to represent constant velocity. I then had to cut the video down in order to measure only the time at which the orange was actually traveling at that constant velocity. So first, what I had to do was calibrate the tracker to the diameter of the orange, as you can see there. Then I had to set up the coordinate system upon which the orange actually moved. You can see the center of mass follow the orange as it rolls across the table as well. In this case, the object is moving in the negative x direction, or to the left across the table. The data that I obtained from Tracker are as follows. The start time of the orange rolling across the table was at 0 seconds, and the ending time was at 0.733 seconds. As you can see, the initial position of the orange was at 0 meters, and the final position was at negative 0.024 meters in the negative x direction. You can see there that after calculating the velocity of the orange, which is negative 0.727 meters per second in the x direction, the negative x direction to the left, that can be calculated by the equation v equals the change in position over the change in time. And the way that we calculate that is by taking the orange's final position minus its initial position over the final time minus the initial time of the object moving, over the final time minus the initial time. After observing the orange, I recreated the motion of it by altering the data in the VPython program. As you can see here, the mass of the orange is going to be 0.25 kilograms. The orange position starts at 0, and the final velocity of the orange is going to be at negative 0.727. That's going in the negative x direction. And of course, we start the time at 0 because that is when we started the clock. As can be observed here, the delta t is only going to be 0.01 because we do that so we can have a more accurate velocity to be calculated for this experiment. Later in the code is a while loop calculating for the ball's position and velocity. The while loop starts with its initial condition that the time is less than the amount of time, the entire time that it took for the ball to travel. The net force, as can be observed here, is going to be 0, which explains why it's a constant velocity for the orange. And the equations have been changed. So the velocity of the ball, or the orange, is going to be the final velocity equals the initial velocity plus the net force over the mass times the change in time. And the position of the orange is going to be the final position equals the initial position plus its velocity times the change in time there. And finally, time is going to be equal to initial time plus the change in time. Here is the model of the orange as portrayed by VPython. As you can observe, the orange, as in VPython, is going to be moving to the left in the negative x direction as well. Here is the line graph and table representing the model versus experiment with the orange traveling to the left. As you notice, both have a constant slope, representing that in both of them, in the real life experiment with the orange and with the model as portrayed by the code, there was a constant velocity of the object. However, there is a difference in where the lines end up. This is going to be due to a possible experimental errors that could have occurred throughout this experiment. Possible errors that may have occurred that could have caused this deviation include human error, such as the movement of the camera as the orange is traveling across the table, an incorrect axis placement on the tracker, or incorrect placement of the center of mass of the orange as it was on the table moving across as well. And that is the explanation of constant velocity in Lab 1 of this physics course. Thank you for watching.